it doesn't have an inverse. If you draw a line through the sine, you can clearly see it doesn't have an inverse, right? Hits in 1, 2, 3, 4, and a million more spots down there, forever and ever. So what they did is they said, okay, sine can have an inverse, but when sine has an inverse, I'm only going to give an inverse from right here to right here, on this portion of the graph. The reason that they chose this portion of the graph is because it passes the horizontal line test. If I go here, only hits in one spot. If I go here, only hits in one spot. Go here, it only hits in one spot. Any place that you pick, it only hits in one spot. If we had picked from 0 to pi, clearly hits in 2 spots. Would not pass the vertical line test, right? So watch what happens. This is a little bit cool. The domain of the blue part, right now, goes from negative pi over 2 to pi over 2. It's our x values. The range goes from negative 1 to 1. Somebody look at the domain and the range of the inverse sine function from this morning and see what the relationship is. Raise your hand when you see it. Look at the domain and the range of the inverse sine function that you copied this morning. When you see the relationship, raise your hand. It's not the same when raise your hand when you think you say it. Be careful. One person, 2 people. Should be looking at your notes from earlier. 3 people, 4 people. Oh God. Tyrese, that's like half a hand. You got that? Tyrese, what do you think?
The domain and range are flipped.
They're flipped, right? Which makes sense because this morning when we were talking about inverse functions, we said that when you have an inverse, you flip x and y, right? So if you didn't see it, this is now our range of our inverse sine function. This is now our domain of our inverse sine function. And when you look at the graph looks even funnier. You don't need to ever graph this, but just so that you know what it looks like. It's going from negative 1 to 1, negative pi over 2 to pi over 2, and it looks a little bit like this. It looks like we've taken sine and we've literally flipped it on its side. Alright? Only reason I'm showing you this is when you go into calculus next year, wherever you're at, they're going to be doing lots and lots of things with inverse functions. You're going to have to know these domains and ranges like the back of your hand, and where they come from, and why you use them. And hopefully you've taken something away. Questions? At what school?
I said, what was school? Oh my gosh.
I thought it said, like in the middle of it, you just start.
Tanika, you're killing me. Tanika, what happened to our domain? What did it become? Tyrese told us.
Oh, it became your range. I mean, well, they flip-flop.
They flip-flop. That was the cool part. It literally just takes both these numbers and it flip-flops them. And when it flip-flops them, that's how we got our domain and range from earlier. And, alright. Moving on. So, inverse tangent. Copy it down. This one also has a domain and range. The domain of our inverse tangent is going to go from negative infinity to infinity. Our range of our inverse tangent is going to go from negative pi over 2 to pi over 2. This makes sense when you think about the graph of tangent. When you think about the graph of tangent, how far down does our graph go? Infinity? It goes down to infinity?
I mean,
It goes down to negative infinity.
negative.
And it goes up to infinity. So that was our range, so that's now become our domain. Our x values, our original domain was from negative pi over 2 to pi over 2, which means this becomes my range. Questions? Okay, so when we go to solve for these, it's definitely the trickier of the bunch. Before we were doing sine and cosine, we were looking for those values. We were saying, is this one of our values in our domain? For these, they can range from extremely simple, like this one, to incredibly difficult, like you'll see on the next problem. So for this first one, we're going to look at tangent. And you have to remember that our only one that we've learned so far, our only trig identity, is the tangent of an angle is equal to sine over cosine. You You should have this copied about 10 times already. Make it 11. Go ahead.